So what's the tea, Nadia?
Well,
Hit him with it.
I ran out of cold ones over the weekend, so today I brought a
Mm.
hot one. I have some mango black tea. Only thing I don't have is the boba. It's disappointing. But did you know that adding milk to tea makes it less bitter because the proteins will wrap around the polyphenols in the tea. Polyphenol in tea is what makes it bitter, and so the casein proteins like wrap around it, and then boom, less bitter. And that, my friends, is nanotechnology. That's the tea.
So we decided to choose this topic because it's this term that gets a lot of hype in the technology world. And so whenever we hear nanotechnology in conversation, it's kind of a vague term, but it gathers a lot of oohs and ahs. It's this futuristic, exciting word that people will say that it'll change the world. So that has some truth to it. Nanotechnology involves the idea of manipulating and engineering materials at the nanoscale. So that means dimensions anywhere between 1 and 100 nanometers. So the science behind it is when you're operating in this small of a realm, the ordinary rules of physics and chemistry, they don't apply. It's all very complicated for obvious reasons, but basically at the nanoscale, there are unique quantum and surface phenomena that come into play that make the properties of nanomaterials far superior to the materials that we see and interact with on a daily basis. For example, carbon nanotubes are more than 100 times stronger than steel and 30 times stronger than Kevlar, even though they're much lighter than both. So this provides a lot of applications in the real world. So as a result, you see so many researchers basically drooling over the endless potential of nanotechnology because it can make this huge impact in so many sectors. I mean, the energy sector, medicine, electronics, basically anything.
What do you mean by quantum and surface-like phenomena?
I mean, that's a good question. I mean, I don't even know if scientists know all the answers because you see quantum physics, you see that term just thrown around, and from what I've learned in class, there's no real answer for why it works the way that it works, because the second you measure it, you're interacting with it, and then you're affecting the movement of electrons, protons, everything in that realm.
Like I shouldn't have skipped out on that quantum mechanics class I could have done last week. I'm just like curious, like what, like when you see like quantum mechanics, like what exact like laws of physics are being broken at that level? I don't know. We didn't really. That might be like out of the
That's
scope
when
of
I need
our
to get my
topic.
PhD. Yeah. A little gone there. I think what's interesting to me is it's this like promise of nanotechnology that Puneeth alluded to, where you get to this nano level and all of a sudden just essentially physics starts to break down or act really weird. And I'd say broadly as scientists, there seems to be a lot of possibilities there that have yet to really fully be tapped into. So it's interesting just because of this ability to use this nanoscale size to imbue a number of properties. So doing a little bit of research, and the US government actually has a big initiative for nanotechnology, broadly speaking. So if you go to nano.gov, you'll find a bunch of resources. But
They're not our sponsor.
They're not our sponsor, by the way, so no free pub. Just to give you an idea for what the sorts of applications for nanotechnology are, and in a lot of cases in our everyday life are a number of applications. One, clear nanoscale films on eyeglasses. Two, computer and camera displays for creating the properties that we now completely take for granted in our computers and our phones to make them touchscreens and whatnot. Three, for windows. Four, for other surfaces to make them water resistant and residue repellent, which is interesting and novel. Imbuing anti-reflective properties in materials.
And for superhero suits.
And apparently superhero suits, according to superhero flicks.
Gotta be, antimicrobial.
Hey, absolutely.
Yeah.
So
I'd like to add another important application. Shout out to, whatever website this was on. I can't verify the truth.
Nano.gov. Oh, wait. The thing I just read was nano.gov. I don't know about you.
Oh, shout out to nano.gov. But also, a very important application, gold nanoparticles can make the pink get ready to be a parent sign or get ready to be pregnant sign on the home pregnancy tests much easier to read. So all the other ones don't matter when it comes to this. But I just wanted to point that one out. I thought that one
I do think that was very important for us to know, Puneeth. Thank you. I really appreciate your extensive research on that
And there's another interesting everyday thing, especially as summer's rolling around and it's getting hot and very sunny. And one of the actually most common applications for nanotechnology in commercial products is actually in sunscreen. There's like this stereotypical image of a lifeguard, and they have, like this white, like veil of sunscreen across their nose. And that was, yeah, so that's actually the reason why that's not a thing anymore. And that's like a stereotype of the past or whatever, is because of nanotechnology actually. And they used to have these larger zinc oxide and titanium oxide particles, which are distinctively white, inside of the sunscreen, which would help reflect the UV rays and whatnot from burning your skin. And now they've actually started to use nanotechnology for that, or nanoscale titanium oxide and zinc oxide particles, so that you rub your nose or you rub your face with all your sunscreen, instead of it looking like this very white color, like a true white color, it's actually now you can rub it in clear because of the application of nanotechnology in that case, which I thought was really interesting.
What does the particles being like on a nanoscale like change the color though?
So it has like the same protective effect, but I think it's something I didn't get into that
Probably
part
the
of the
optical
research.
properties, right?
But yeah, it modifies
yeah,
something about the
yeah.
optical properties, but I don't quite know the like scattering mechanic of how it makes, how it transforms it from being white into something that's clear. But I feel like we've, had interactions with sunscreen, and it's still like oily, and it's still obviously there, and it obviously still works.
It's implemented in the world today, right? This isn't just
oh yeah, no, I mean
a
like
future R&D kind of situation.
Oh no, this is like everyday sunscreen is
I
like
mean,
this now.
We're using it.
Yeah, we're using it like every day, which is crazy.
I think that's
Yeah.
important to understand, because there's around this term nanotechnology, everybody just kind of puts it off as like it's going to happen in the future, but
Or it happens in the lab sort of thing.
right, it's still all early stages, but in reality, we see its applications showing up even right now that hints to what it can do in the future.